Good evening, everyone. This is Shashi Kant, and today I am going to, discuss something practical, not limited to theory, about the roadmap for a ECE graduate student, how they can enter into VLSI industry, and they can become a chip designer. We'll start this session with a very simple question that we should ask from ourselves only, that how many of us are using a device right now? The answer probably will be, almost everyone we are using device, either we are using smartphone or we are using smartwatch or any other thing. But on a simultaneous note, can we ask ourselves that how many of you that knows how this chip that is being used inside this device is being designed? Okay, so that is what a gap between using technology and building technology, right? And that's what we are going to discuss today. We'll be bridging the gap between this discussion. Okay, and also let me be very honest that ECE degree with electronics and communication engineering is not enough to become a chip designer. Okay, but the good news is what, that a proper mentoring, proper roadmap, proper skill set will definitely allow us as an fresher, as an ECE graduate, to enter into this VLSI industry or fraternity. So today, all these things will be discussed, and I will share the knowledge which is not limited to the textbooks, but I'll talk about what actually happens in industry, how many of ECE grad students struggle to crack the interviews of VLSI, and how you can realistically become a chip design engineer, right? So this is based on real industry experience, not on our my assumption. That's what I see in my company. That's what I see in industry also when I have discussion with the other candidates also. By this end of the session, you will have a very clear roadmap in your mind that how you can start your journey to become a chip design engineer. You will have a clarity on the skill sets, that what exactly you require at the end of this session, and confidence. Definitely this session might give you a confidence to start to think to become a chip design engineer. So we will talk about the semiconductor era, because we are in a golden time period, and everyone knows that we are using lot many chips. Okay, everything whatever we are using, this is fully dependent upon the chips only, right? Okay, so again the question comes in our mind, can we just think we see in our surrounding, and can we ask ourselves that is there anything which is not using a chiplet or chip? The answer again, it will be almost nothing, right? Because if we see around our daily life, we are surrounded by the chips, and that's what the theory, that's what the survey also says. Okay, in 2025 somewhere, every person, if you just talk about the global population, every single person is using more than 100 chiplets, right? And that the demand is to be increased in by 2030 to be more than 250. You can see in next 5 years the demand of chips will be 2.5 times, right? So if you look into our daily routine, from smartphone to smart watches to cars, right, to AI systems like chat gpt and all, to like our home appliances also, maybe refrigerator, maybe AC, maybe washing machine, maybe smart fence, everything is dependent upon the chip, everything uses the chiplets. And we can just compare with the 2020 when there was a global shortage of chips, right? Lot many cars were delayed in the we can say delivery because of the chip shortage. And that's the reason many of the countries like us, India, they are starting investment in the semiconductor industries. under semiconductor mission, or maybe we are establishing new fab labs, or we are supporting the startup companies also. So definitely the chip design engineer opportunities are very very high. The demand is because high, so the requirement of the skilled engineers would be high, right? But again, I am focusing on the skilled engineer. That is what you have to understand. The demand is not high for the a normal engineers, or maybe the engineers or students who don't have the proper skill set. Okay, so only for those who are skilled, who are trained. Okay, if you see, you know the reality of electronics and communication engineers, as far as the curriculum is concerned, we people are very good in theoretical foundations, right? But what we lack is the limited practical exposure. Hands on is missing. This is a gap, basically, right? Lack of industry tool experience, that is also a biggest gap in the industry and academics. And no structured career roadmap, right? So these gaps basically makes the most of the EC graduate to struggle in the interviews. But these gaps are these are not such gaps which cannot be bridged. They are totally 100% bridgeable gaps, right? How? In few slides I will show you the roadmap that how these gaps can be bridged. Before that, let's talk about the chip design engineer. Who are the chip design engineers? So these are the persons, the main pillars. They build hardware logic which becomes actual silicon, which basically is implemented on the semiconductor. You can think like this. If you talk about the software engineer, okay, what they are doing, they are again writing the code, but that runs on the CPU. Okay, these are the codes that running on the processors. But what chip design engineer does, they are actually coding to make the CPUs, right? We are building the CPUs, and software engineers are coding to run their portion of the code, or maybe their design on the CPUs. So that is what the difference between this. I have kept some important roles that a chip designer does, starting from the RTL engineers. They basically write the logic, they code the logic. Verification engineer will just check the functional correctness of the designed hardware that is coded by RTL engineer. And the physical designer actually converts this coded hardware into the actual layout. Apart from these roles, we have several intermediate roles also, right? There are not only three roles in the entire chip design industry. There are a lot of other roles are there. If you talk about physical designing is concerned, we have PNR engineer, we have STA engineer, we have synthesis engineer. So that is what is available. But these are the main foundation of the chip designing, which is being written, or maybe code is written, code is verified, and then this code is basically converted into an actual layout. And out of that, if you see, the verification engineers are very huge in demand. If I take in data of entire chip design flow, 60 to 70% of the entire VLSI fraternity works in the verification field only. Because early verification, this is saving our cost, this is saving our time, this is giving a design which is we can say it is just following the all the norms of the industry. Okay, so all these things are there. That's why the verification engineers role is very crucial and very demanding nowadays. Let's take some time to understand what exactly this chip design flow is, how and what are the various steps involved in that. So whenever any new requirement come with the company, first of all the company understand the requirement of the customer, understand the demand of the customer, and based on that it makes a survey, it just innovate the things, it research the things, and produce or prepare a very good documentation. which gives everything about that chip to be designed. So this is basically a specification, kind of thing. Okay, so this is a framing of a document which contains all information about our product. Then this specification basically is also planned with the architect, right? So architect basically they plan, they give a proper architecture of your chip, that how many components we are going to use, which component will be placed at what level, what will be the size of this component, all these things. Because we know when you are going for any product development or maybe anything, a proper planning gives a better result at the end. Okay, so this documentation also will include the structured architecture or maybe planned architecture, okay, of your chip. Then this document is sent to the RTL team, which is intended to write the code for that hardware. They will be again dividing the hardware into small parts because nowadays complexity is increasing. Okay, so we again divide and write and again integrate this complex design to become or make a final design. So RTL team will be using the hardware description languages at this moment, which will be actually writing your code into the soft form. Generally we have two hardware description languages. You must be aware about that. The one is VHDL and the other one is Verilog. But most popularly, VHDL Verilog is used. This is mostly used in the industry. Okay, but again, any of the hardware description language can be used to design this code or maybe write this code. Then coming to the next step where the functional verification is to be achieved. This checks the functional correctness of your design at every angle. Okay, and parallelly we see that the behavior of your design when any abnormal things are also encountered, right? So this again in verification step we use the HVL hardware verification language, which is most commonly used language is system verilog, and there is a uniform methodology that is called UVM. So these are again used at this level. Once the functional correctness is observed, we are done with the verification. Then this RTL code, is converted into the netlist, that is a gate level diagram through the synthesis. Okay. Then physical designing is, done, in which we will be importing the design, we'll be choosing some technology node and working on floor planning, placement, routing, static timing analysis, and all these things. And finally we get a layout at the end of this physical design process. This layout, which is in form of GDS2, is sent to the manufacturing department, fabrication laboratories, and finally we get a chip, that is a tape out, which is known as a tape out. All right. So, in this entire process, if you look through this entire process, again, I have kept only the major steps, but there are several, intermediate steps also, which will be involved in that. And this process is not a, one day or maybe 1 month process. It required large amount of time. It required large amount of, manpower, and the cost is also very, very high to build one chip. And that's what I told you, that verification engineer is very crucial in the entire chip, because the verification is done at the number 3 state only. If suppose we don't do the complete verification at this level, and at here or maybe at tape out time, when it is validated, we get to know that this chip is functionally having any bug, then there is no use of that. Again we have to start from the scratch only. So all the money, all the efforts, all the time which has been invested on this chip designing will be all in vain, right? So that's why the role of verification engineer is very crucial in this. Okay, so, if you just talk about the skill requirements, I have kept some very important skill requirement. Being a electronic grades, what you should know if you want to enter into the chip design industry, or maybe you want to become a chip designer. So, out of these skills, digital electronics is very, very important. It's mandatory skill for everyone. All right. So you should have a very good knowledge, understanding about the digital circuit designings, and as well as the analysis of these circuits. You should have a introduction or maybe some good knowledge of CMOS fundamentals also, because PD engineers, physical design engineers, they also work on the MOSFET level only. So a good understanding of CMOS working and then their characteristics and everything should be there. Definitely computer architecture knowledge also is required, because when you plan the architecture at micro architecture level, you should understand the connection point of view, maybe pipelining or maybe data path designing, all these things. The computer architecture help you to understand the proper connection, and they will give a better idea to that. The coding requirement, if you see, the hardware description language Verilog and hardware verification language System Verilog is needed. UVM is also needed, but for freshers, industry doesn't require in-depth knowledge of UVM. But yes, these two languages are to be known thoroughly by everyone. And top of the above, you should be very good at problem solving and debugging. My dear friends, I would like to tell you the real experience, that the debugging and the problem solving require a lot of time. See, we write the codes. Okay, probably we can write the code fastly, but the finding the bugs, actually how this code runs, what will be the requirement of this code and how it is connected with different components, that require a lot of time. And that kind of bug management is required, and it comes from the debugging only. Okay, so this is a saying in our industry: the better debugger wins. Who debugs the code fastly, definitely he can achieve their goals, or he can achieve the target, whatever the tape out we can say, release we can say. They can do the release, give the release faster. Because in industry, there is a limited time. Everything is on deadlines. And when you have any bug, that single bug takes a lot of time. So the bugs are very complex. Okay, so sometimes we see when we write the code runs fastly. Okay, it runs perfectly at first time, but when you actually compare with the requirement, that requirement doesn't match with that code. So that's what the challenge in front of the engineer, that you have to fix that gap. The code is running but it is not achieving the target, so we have to now match this expected value with the output value that is coming. So that is what the challenge in front of that, and that comes with the experience of debugging. When you are a good debugger, you can definitely make this code near to the expected whatever requirement. Okay, so these are the skill set requirement. Definitely is what I told you, that we people are, means as a electronic grades, you are having less exposure to the industry level tools. So I would like to just give you the idea of few of the industry standard tools which are very famous. There are sort of other tools also, but if you go for the simulation purpose, we can use model sim, questa sim, that is of mentor graphics, or maybe synopsis also provide the VCS tool. Cadence and Accelera also, they have their own simulators, right? Same, we want to do the synthesis, then we have a design compiler by synopsis. We have like AMD Vivado also is very good tool that we use for the synthesis purpose. Similarly, the Cadence also is providing. Please mute yourself. Cadence is also providing the tool and so on. And for debugging, okay, there are the tools by Synopsys, that is Wordy is a tool which analyze the waveform and debug the waveform and gives the suggestions that okay, the problems is available here, you can fix it. Okay, there are other tools also, but what is the key point about that? Don't be over dependent upon the tools, right? If I say that I mention in my resume that I know these tools, all tools, but you are fundamentally weak, nobody will hire you. But if you don't know that any tool, but you are fundamentally very good, the tool we can learn within a week only, right? So what is the key point? Definitely it will give a plus point to your resume, but you should more focus on the fundamental things, right, rather than a tool focusing. Okay, so this is something that will give you a roadmap to become a chip design engineer. These are the six main, we can say, ideas that everyone should think and apply in your life. You should build up strong fundamentals. You should work on the fundamental things. Try to ask yourself. See, let me again give you an example that being an electronic grad students, we are preparing for the exams, right? We just prepare the subject to write the examination, and most of the universities, most of the institutions, they prepare the question paper focusing around what and how. Rare institutions will ask the questions related to why and where. This application based, and then again, you know, they are giving a questions, or maybe they are giving a problem set that are based on some critical thinking, and that's what it's a lag, right? So you should, you should ask yourself whatever you are studying. You should ask yourself why I am studying this. What is the application where I can use this? You should ask, okay, if I have one component like this, how can I reuse the things? Because engineers are known to reuse the things. It's not that everything we will design from the scratch only. We should think, if anything is available to us, how can I use in a better manner? Okay, so this comes under the fundamental things, right? Okay, so your fundamentals are very, very, it should be very, very strong, right? This is a requirement of the industry also. And if you want to become a chip design engineer, you should also think about that. Then learn the relevant skill set. I am keeping this skill set relevant to the VLSI, maybe front end mostly. So that's why I've kept this very log and system log. Suppose some of you want to be a physical design engineer, so you should learn the concepts that are relevant for physical design engineers. If some of you want to be a software engineer, so you should learn these skill sets, right? Whatever the relevant skill set. From the day one, you have to plan that. Okay, I want to, means the goal should be very clear, that I want to be this. Now you should start your preparation from the day one only. You should make a proper chart. Okay, in first semester I will learn this, in second semester I will learn this, in this manner, right? The main problem of the ECE grad student, that we don't focus on the real world projects. We just we submit the projects for the sake of just formality. This is what it is a fact, and there we lag, because industry demand something different from you. If anyone is working on real projects, like if I give an example, in VLSI industry, real projects are like ALU is one of the very good project. FIFO buffer is very good project. I will be explaining some concepts in next slides also. So they will attract. These are the eye-catching projects for the interviewer also. They will think, oh, he has worked on these projects, means he has something different. You should be different from the crowd, and these all will make you different from the crowd. Learn the latest technologies, latest skill set that is required by the industry. Like verification engineers, the latest is UVM. UVM, if anyone knows, you will be again different from the crowd. You will be, look at a very special person from the crowd. What you need to see, you need to just explore the opportunities of internships and good trainings, because learning every day, new learning will give you a very good confidence at the end of the graduation. So you should look, many of the companies, they open up their internship opportunities, right? Or maybe if no opportunities are there, then you should think of the relevant training, not for the sake of formality, because most of the institutions have summer internships, and maybe some 6-month internship in their curriculum. But what most of the students, they think that they will get a certificate from anyone and then they will submit it, I'll, my formality is over. And that is what they are lacking. So you should really gain the knowledge, during this period, summer internship, or maybe the 6 month internship, that is called practice school course. And last, you should start preparing for the interviews, right? From the day one only, your target should be very clear that I have to crack the interviews, right? So you should learn how we can appear for the interview. What are the tactics we have to use in the interview, because interviews, facing an interview is also an art, right? Most of the students, they have very good knowledge, the CGPAs are more than 9, but they are lagging to face the interview. They have the fear of the interview. But some of the candidates who have like average CGPA, they have the knowledge, but they are presentable. Basically, you can present your knowledge in a effective manner. Definitely, company would go for the second candidate rather than first candidate, because company wants the candidate who can work well, who can explain well, who can be a good team player. All these things are necessary for that. All right, everyone. So what I was talking, that the projects, so I am giving 2 3 project ideas that as a electronic grades, these are relevant for chip design industry. If you do carry out these projects, okay, semester by semester or maybe year by year, okay, then definitely it will give a very different, we can say, exposure to you people. So like you can start your project with, let's say, a very simple ALU design, which is the main component in the processors. You can perform some different arithmetic or logical operations. You can focus on the combinational and sequential circuits, right? Okay, that will, this project will be able to give you the idea about the arithmetic operations, some status flex also. What is my suggestion here? But don't just code, right? Because you can find these codes on the chat GPT also. What you have to do is you ask yourself, right, that what happens when overflow is there. Now these are the things that you have to think beyond the box, right? You have to ask yourself, what happens if suppose you are working on signed or unsigned numbers, how differently we have to work on that. You have to understand the edge cases also, because for verification engineer, we have to understand the corner cases also, where we can verify this design. We have to not limit on the directed only. We have to see some out of the box cases also, that will make your design to be working abnormally. Okay, so this thinking will make you industry ready. That critical thinking basically enable your career towards the VLSI industry. Same, suppose next phase you can design the FIFO, which is very very important component in communication, right? Everywhere you will look, whenever we are communicating with two components, transmitter receiver, there will be a FIFO. This will be acting like a buffer, right? Which is used for synchronization purpose. Every real chip will be using this for data buffering, for communication purpose, and for CDCs, clock domain crossing. And what you will learn from here, handling the pointers, handling the this full and empty conditions, okay. And you will be learning the FSM of this FIFO, how actually this is going from one stage to another stage and coming to back, right? And you can go for, you can start your learning from synchronous, and then you can advance it by putting asynchronous before, just taking it different kind of pointers for write and read pointers and all these things, right? Okay, so again, this is the FIFO. If you add this FIFO in your CV, this will be again the most focused area for the interviewer. The top interviewer will ask you the questions from FIFO only. They will not go here and there. So when you work on real projects now, your interview is also pointed towards the main focused area only, right? Maybe you can go for some advancement also. This is what I am just giving you the journey from the year 1 to year 2 to year 3, or maybe you can start if anyone starts from second year, then in second year you can work on ALU design. In third year you can work on FIFO, and in fourth year you can work on AXI protocol, right? Or maybe AMBA protocol. Because today's era is of SoCs. Everyone is well aware about that system on chip. And on this chiplet, because there are processors also, there are some high speed components are also there. There are some low frequency components are, these all are interconnected. The on chip protocol which is mostly used is AMBA protocol. And among this AMBA, because AMBA is also having three protocols: APB, AHB, and AXI. So AXI is the very vast protocol. So if somebody learns this AXI protocol, the handshaking process, maybe read write, topologies, then that will be adding some feather in your cap, and this will be giving a edge to your career. Only basic understanding itself it will be giving. If somebody goes in depth, that will be very very good. But a basic idea of this AXI protocol will be adding some feather in your cap, right? So you can start learning from the AXI light, and then you can go for the some advanced AXI protocols also. What industry expects from a candidate, you should understand that also. And that is what the roadmap I have covered, right? The same things are there which is included in the roadmaps. Industry expectations is also, you should be very good at fundamentals, you should have the hands-on experience, and should work on some real projects. Your debugging skills should be at par. That is what the requirement of the industry. We don't need only coders, because only coder will write the code and then okay, he will be just standing their hands. I'm not worried. But actual problem starts after writing the codes. The bugs comes, expectation doesn't meet, then these debugging skills will you know help you to release the product fast. That's what saying I told you. A good debugger wins the race. Understanding of the flow, VLSI design flow. This is expectation, and you should be a team player also, right? You should not only focus alone only, because there will be working on the team, right? Because it's not like that in a VLSI industry individual is working on individual tasks. No, there's a team and everyone has to collaborate itself. Right? So these are the expectations that you should also keep in mind, and accordingly you have to prepare your things, right, to become a chip design engineer. And what we do, we know the common expectation, but what are I want to highlight here some common mistakes that ECE grade or maybe engineering student does. Again, they just ignores the fundamental things. They only understand the things on the upper level, but they don't want to go into inside. What is the background behind that? What are the mathematics involved in that? If something is there, what is actual fundamental thing about that? And that is the biggest mistake you people do. Again, the project work, right? I have taken an example, and that is what the most of the student does. They only submit the project which was carried out by some of your seniors. You will find it on the internet. You will just copy and paste, and you complete this project work within a week. You don't know the ABCD behind this project, and that is irrelevant of your degree also. That doesn't serve any purpose. You should work on a project which is really useful. If you want to be embedded engineer, your project should be towards the embedded systems only. If you want to be a software engineer, yes, definitely your project should be relevant to that only. If you want to be a VLSI engineer, see, that is what, if some resume comes and I see your projects, none of your project is relevant to VLSI industry, would you think that I will be giving you priority? And another resume is having 2 3 projects which are relevant to VLSI industry, definitely I would prefer to go with that candidate, because if he has worked on these projects, definitely he has something that is not available with you. Most of us, they are over dependent upon the tools, because there are some AI tools also, some advanced tools also, they can write the codes. We should not be over dependent upon the codes. We should instruct the codes, right? That okay, you should be, the tool basically should work on your instruction. You should not work on the tool's expectation, instructions. And that's what, because I usually take the classes, what I feel, that like I am teaching the very low. I have make made understand all the student to write the code. They have written the code and then they run the code and they get the error. Now most of the student don't know how to read the error and how to rectify the error. They say that tool will do everything. It's not like that, my dear friends. You have to do the brain of a person should instruct the tool that okay, this is an error, remove that error by just removing that. Okay, so we will go and we will rectify the code. Tool itself will not do anything. And lack of consistency. See, maybe after today's session, you will be motivated and you can think, okay, I will start my journey, I will study. Maybe 1 week you will study with very enthusiasm, but then your interest becomes less. That's what you have to work on. Consistency and discipline is very, very important. If you don't have consistency, definitely it will not help you to achieve your goal, that is a VLSI engineer, because this require a lot of efforts. This require a lot of consistency, discipline, patience. Everything is required. There will be lot challenges in the path. Okay, I don't say that this will be an easy journey, but it's not impossible journey. You can achieve. Most of chip design engineers are from us only. They started their journey from the scratch, zero, and they achieved their goal. Why? Because they keep on working, keep on working, keep on working. They did not lose or they did not, stop. So that's what, you have to work on these mistakes that generally, electronic grade student does. Okay, so you should work on that. Don't be like start then stop and then again restart. Again restarting will be from zero only, that's for sure. If you'll break the things, if you have a gap, again everything will be vanished. So you should have a consistency. How you can stand out, you can look differently from the others. Again, you should have a good project portfolio. That's what I have given you the idea, that if you want to be a chip designer, definitely your project should be relevant to this VLSI industry or chip designing. That will help you to you know become a different from others. Okay, crowd. What I suggest to everyone, that whatever work you are doing, you try to add this on GitHub repository. Try to show it on the some platforms. There is very good platform LinkedIn. You can show that I have learned this, I have worked on this project. Okay, and if you want to know more about my project, you can go and visit my GitHub repository. Simultaneously you should be answerable also. Somebody asks you, okay, how, what you have done, what are the cases you have understood, what are the edge cases you have covered, everything you have to do, because if you are doing really, then you will be answerable for that, right? And you can guide them also, you can become a mentor for them also. Yes, internship experience will add on again a feather in your cap. If during your graduation you take maybe one or two good internship, then it will help you. It will be again taking you to different, right? And practical certification, some relevant trainings, okay, that will be increasing your core skill set, and that will be making you employable. Please again remember, if you are joining any training, you should have a very clear cut target in your mind, that I have to do hard work. Okay, I have to work on my skill sets. I have to follow the guidelines which is provided by the mentor. I have to be very disciplined. I have to be very consistent. These all are the things that will help you to grow your skill set, grow your career, right? This is something that you will, if you start journey in the VLSI industry, freshers always will be allocated at, as a design or verification engineer. Initial role will be training, then later on you will be, on the payroll. So you becomes a verification engineer, design engineer, or maybe physical design engineer, whatever. The next promotion you are getting as a senior engineer, then you go for lead engineer, then architect, then maybe you are country head, or maybe CEO, maybe director. So these are the career growth. There are a lot of other profiles also, right? But this will be your career growth if you start journey. And this is not like you are having a 20 experience. This can be achieved within 10 years of experience only. And you won't believe, but the most, you know high paying jobs, if you see in across the globe, this is a VLSI engineer only. Okay, but again, that should have a real skill set, that should have a relevant skill set. I'm telling you about the future of chip design because that will help you to understand that demand of chip design engineers. That now chip designing is, into the AI driven chips also, because we have lot many very high computational machine learning algorithms. So we don't have any hardware, so we are now into the accelerator designing, or maybe AI driven chips also, and AI driven tools also, right? Chiplet architectures are also, into the future of the chips, advanced semiconductor nodes, right? If you see 2 nanometer tape out, and maybe soon you will get a 1 nanometer tape out, and then people are thinking about, stacking of the chips, and maybe angstrom also we can go. So there is a one very, important rule or law is running behind every chip designing, that is Moore's law. So industry is working or growing beyond that Moore's law also. And because of this future, bright future of chip design engineers, there are growing opportunities across the globe, and in fact in India also lot of opportunities are there. All right. So this era will be, now in gradual expenditure only, right? It will be growing rapidly, and next 10 years are the golden era for chip design engineers. This is the industry insights. Okay, that industry works on real world design challenges. The design complexity or debugging complexity is increasing day by day, because the complexity of chiplets are also increasing. Yes, we have to focus on the teamwork. So in industry, definitely it follows the team players, right? Okay, it follows the teamwork policy, and that is what the importance of the teamwork, so that we can achieve our products, or we can release our products at faster rate. And every day there is a new learning. So the day you stop learning, this is a very good saying. See, so many layoffs were there, and I was just having a discussion with my, senior persons, that why these layoffs are happening. And again, if layoffs are there, then what will be, the opportunities for these candidates who are working, let's say, 20 years from this company. So the problem is for those candidates who stopped their learning. If anyone who is, learning something new every day, or maybe every week, or maybe every month, but he is, learning something new, it's learning is continuous, he will never ever face a problem. If layoff is there, some other company will be giving opportunity to them, because he is having a relevant skill, and it is, having a demanding skill set that is there in the market. But somebody, suppose I'm working with some company, and some company is working on some particular, era only, right, area only, and I don't explore some new areas, then definitely it will be a problem for that. So if you are following the continuous learning principle, definitely there will be no challenge. If some company is not there, then definitely you can go for another company also. And that is what, I heard one, very motivating lecture, and in that case it was saying like, if I just look for the formula 1 power infinite or 1 power, let's say 1000, it doesn't impact much, right? It will be same only. But if I just change, I add on something 1.01, 1% only I'm increasing, and then 1.01 power 1000, the difference is huge in long term. So this is what the impact of continuous learning. If you learn only 1%, it will be impacting a lot in the, you know long term. So you should, focus, you should, keep this thing also in mind. So every day you should learn, and industry works, industry motivates everyone. So these are my final advice to everyone, that start early. If somebody is first year, or from the audience side, you start from today only. If somebody is from, third year, fourth year, definitely this is not the right time, but yes, you can put more efforts and you can achieve your goals. Okay, but the suggestion is you start early as soon as possible. Stay consistent, that is very important. Consistency is very very important. Okay, focus on fundamentals. My every discussion is emphasizing on this point. And work on the real projects, explore some technologies, explore some industry level tool, work on these tools. Okay, rather than just copy and pasting the codes, you write your own code, take the help of your mentor, right? Go for good trainings, go for some good internships. So this is my, final advice. Okay, you should not think that, okay, I will start now after examinations, I will start after my semester, and no, you should think that I will start from today only. Okay, so from these all things I will conclude my thing, my discussion. Okay, the journey of your, ECE student to chip design engineer starts today. You can build something that is used by million of us, right? And full careers offers, maybe, you will be achieving with this. Take it seriously, it will be very very important session for you. Okay, that's all from my side. Let's take some queries from audience side. If you have anything, we can, I will be very happy to answer your queries. Thank you everyone for joining this session. I hope this session would have given a clear roadmap to you people, the requirement of the industry, what generally we make mistakes, and how we can work on these mistakes. Yes, Garvit, please unmute yourself and drop me a query. Garvit Kumar, you want to ask anything? Okay, anyone? You can drop your queries in chat box also if you are unable to unmute or you don't want to unmute yourself. Shall we wait for some time? Yes, please, Amulya.
Good evening, sir. My name is Amulya. I'm currently a final year ECE student. So I just wanted to ask, is BTech in VLSI sufficient to build a career, or would pursuing a master's degree be a better option?
Your voice is breaking, but what I understood from your question is BTech in ECE is sufficient to enter into VLSI industry. Am I right?
Yes, sir. Yes. Or master's would be an option to
See, Amulya,
withstand in this career.
degree doesn't matter. That's what I am saying. A candidate who is having only BTech in ECE or BTech in VLSI, okay, and having very good skill set, that is what I require. and the candidate who is having MTech or maybe in fact PhD also, but he is not having a relevant skill set which my company require or which a industry require. So definitely my preference will go for the candidate with the right skill set. Degree is just a piece of paper for us. Yes, definitely we want the master candidate, but that can be done. There are a lot of good institutions, even IITs and all, they also providing the degrees for professionals. Okay, so just getting a degree is not a purpose to be solved. We have to parallelly get the skill set also, right skill set that is required by that. All right.
Yeah, thank you, sir.
Okay, okay. I hope I am answerable to your query.
Yes, sir. Yes.
Okay, thank you very much. Thank you. Anyone else? Yes, please. So, Garvit, let me take his query. So, I want to know, verify. So, Garvit, the verification or designing happens for one chiplet only. It works for one, right? Maybe we can test, validate randomly. The company validate it randomly if it is doing the mass production. But all these things happens for one. When one protocol, one complete setup is available for one chip, that will be the same for others now. So we do not have to change this verification topology for other chip, because that will be doing the same thing. Okay, so anything new is done, that is for one chip, and then it goes for mass production, right? For every chip this same process is not repeated. Only the last process manufacturing department will just do the mass production for that. But yes, validation happens for the random chips, right? Okay, because we can randomly select. That is what the quality assurance department does. He will pick up some random chips and he validate, right, whether the chips are working as per the expectations or not, right? Okay, yes, Rakshita.
So my doubt is, so when we search for internship in LinkedIn or any other website, so there are many roles mentioned over there.
Hmm.
So as the first internship, when we start, so which role shall we go with? Because every role we should know little bit knowledge,
Hmm.
but later on we decide one as a career. So as a starting, we should go for back end or front end.
See, both are equally important, right? I am not
Mhm.
saying that front end is good or back end is not good or maybe any. Both have the equal impact. But what I told you, you have to see the opportunities also. Number of opportunities in every field, and that is what, if large number of opportunities are there, definitely the success rate will be high. Okay, so if I you ask me, if suppose instead of you I am the candidate who is looking for the internship, I have a good skill set relevant to front end, I know the codings, I know these things, though I know the back end also, a bit of back end also, but still because requirement is large in front end, I would prefer the front end. If suppose my skill set is my interest is very good in back end, then I would prefer the backend, though opportunities are high in that. I don't care about that, but my interest is in physical design. So that is totally depend upon the candidate, totally depend upon the requirement, the skill set, either it is matching with my current skill set or not. Okay,
Yes, sir. Yes, sir.
okay. See, there are a lot of companies, Garvit, that offers the like Synopsis offers, okay, Cadence offers internship. Maybe some small companies also offers internship, right? So you have to what you have to do is one thing, you update your LinkedIn on regular basis. Another thing, you follow the companies, very good companies which are working in the required domain. You follow that. So anything is coming, anything is having something new from these companies, they will be notified. And go and visit their career pages. Okay, so their career pages will be showing you any openings are there on the in these companies or not, right? So regular efforts, regular visits on these things. Please target like half an hour I have to give to this. I will visit the career pages of different companies, I will visit the LinkedIn, I will update my LinkedIn, I will see what is new on the LinkedIn. There are a lot of things on that that will help you to grab the opportunities, right, rather than sitting idle or maybe seeing the reels and all these things, right? So half an hour daily you can, if you give, definitely there will be, some opportunities will be visible to you for these companies. Okay. So how is AI going to affect VLSI industry? They say it will replace humans in some software IT jobs, but how it will impact? So see what is happening. That is very good question. Definitely there will be an impact of AI in the jobs, but that's what we had a discussion in our company also. Okay, this will not replace the humans. AI can code, but AI can't debug. Manual intervention is there, and we have proved that also. If suppose I planned, right, we compared different platforms like Chat GPT, Cloud, or maybe Copilot and all. If you just ask them to plan a verification environment, or maybe planning for a verification for maybe some USB or some latest nodes, they were unable to plan in an effective manner. Definitely, a skeleton was given by the AI tools, okay, but the proper, a very effective, very good plan, very good verification plan was not given by that, and that is something happened in the RTL also. If suppose I ask AI to write a cost-effective architecture for any hardware, he or means that AI will not be able to understand what do I mean by cost effective, because we as a human, we can think about different aspects of that, but AI is having only one flow. He will be giving, and just making your code which is as per the train, right? Maybe later on that can be, but again, complete AI will not be able to work in the chip design industry. Okay, let me be very honest. There will be definitely human intervention needed. Yes, I agree in that point, that whatever the work was happening, it was taking, let's say, 5 days. It has been completed within maybe 5 hours, or maybe next 5 to 7 hours only. So yes, speed is very high, throughput is very high, but again, cannot replace humans. That is not possible. All right. Okay. What about the analog design of the chip? Can we switch after joining? Yes. See, inter company switching is there. If this is best part of verification engineer, that a verification engineer can go into different fields. He can, if you are joining a verification, maybe a digital design engineer, and now you are willing to go for physical design engineer, or maybe analog design engineer, or maybe AMS engineer, the doors are open for you, because you have to learn new skill set, means some additional skill set. These will be required, right? But if you are working as a physical design engineer, you want to become a digital design engineer, that will be really difficult for you, because learning this language, right, Verilog, system Verilog, UVM, it is bit difficult when you know have a gap in between that, because PD engineers or these analog engineers, they mostly focus on the tools layout level, and we actually develop the brain of the chip. We actually develop the logic, right? So that is a difference between that. They don't have any, they don't work on the logic. They only fix the box, maybe a timing related or maybe anything related, right? And mostly work is on tool only. But here they mostly work on the paper pen, develop the logic, and then think some optimization also. So that is what you can switch from one area to one profile to another profile. But from digital to another profile will be good or easy for you. From other profile to digital, it will be bit difficult. I'm not saying it is impossible, but bit difficult. How to crack the VLSI interview tips? See, uh, the main, we can say key point about the cracking the interview. What I, because when I take the interview, within 1 or 2 or maybe 3 hours, we cannot judge the candidate perfectly. So that's what I, whatever the skill set I told you, you should be good at fundamentals, you should have the relevant skill set, you should have the debugging skills. But these are the things. Apart from that, what I observed, and what mostly they observe, is positive attitude, attitude towards learning, attitude towards the working, attitude towards becoming a team player. So this is what I observe. And aptitude is must. Whether you means whatever the learning you have done, are you able to think the application of that, that how I can apply these things, where I can apply these things. All right. So that is what additionally you have to work on. And definitely soft skill is must. If you have good knowledge but you are unable to express your knowledge, it's of no use. So effective expressions, effective you know you know things that will help you to crack the interviews, right? I'm currently in final year applying for jobs. My resume is not getting selected. What are the major reasons for not getting selected? So maybe your skill set is not matching with the requirement. Maybe your experience. See, that also we make mistake. We don't see the complete job details. Every job detail will give an idea of requirement. Suppose you are applying for a job which require experience of maybe 3 to 4 years, and you are a fresher, and you say that I am not getting any offer, or I am not, my resume is not selected. So if a relevant experience is required, relevant skill set is required, if still not able to sort your resume, then something projects are missing, some good skill set is also missing, or maybe some resume you have to just take the help of AI tool also, and build a very good AQI factor. That is what whatever we call very good resume also you can make, right? So that is what the reasons can be there. Okay, I'm not sure what could be the reason for your resume, but these are the possible reasons for that. All right. How to build up logic to design something ourselves? See, that will come with the theoretical concepts only. Okay, whatever thing you want to design. Okay, so you should have the theory behind that. This theory will also help you to design the logic only. There is nothing rocket science, there is no ready-made things that okay you go and learn the logic development from here. No, it will be coming from the experience, it will be coming from your practice, it will be coming from your critical thinking, it will be coming from your learning only. This comes from the learning only, right? All right, everyone. Anything else? Yeah, I will be sharing my LinkedIn ID. You can just search. Just give me a minute. Okay. Anyone else has any questions? I'm opening myself for next couple of minutes. Otherwise, we will just wind up this session. Right. So, anyone has any more questions? So, I would be happy to connect with you people. You can connect with me on this LinkedIn ID. Yes, please. Sai Siri. Okay.
Sir, good evening, sir.
So, Insight Help, good evening, sir. Okay, I'm good at digital logic design very low, but my guide provided an internship in analog domain, cadence tool. I want to learn that tool, but other teachers tell me to concentrate only on one domain, either digital or analog. So yes, definitely this is something good suggestion from your teachers, that you should limit yourself in one domain only, because if you go in different domains, you will not be perfect in one domain, right? But still, like if you have good opportunity from one company, right, it can be a good opportunity for you. You can learn this skill set and you can make yourself ready for acquire in that company only, right? And there is no such thing that if you are good at digital and you are learning some other domain, so you will not be good at that. Just keep this study also. Okay. And you learn this also, right? So if you feel that you are very good at digital and very low, so you should learn these skill set daily, and apart from that analog also, so you will have plus point on that, right? Okay, so you can think in this way also. Sai, how many projects? There is no such fixed numbers, Niranjan, right? But at least 3 to 4 good projects should be there in your resume, and that to be of relevant. Don't write like okay, uh, comparison of this or maybe this should be result oriented. You should have some simulation results. They should have some your own logic development, right? Okay, maybe you are not doing anything new, but you should be able to understand. You should able to make others understand that okay, I have done this. You are very perfect in this explanation. That's all. Like, I'm just taking an example of FIFO. So you should know that all the concepts of FIFO. You should know the accessing, reading and writing in the FIFO. You should know if FIFO is full and still I'm writing, what will happen, how we can control these flags and all these things. So the depth information should be there, right? I don't expect that a ECE grad student will do something innovative, right? That is not possible within that 1 month or so. Yes, 6 months you can do something new, right? You can add something like, I give an example. You work in maybe AI accelerators, right? So you can add something which is not available in previously generated or previously designed AI accelerators. So that can be a good project for you. But that is at end level. Initially you can start with very basic projects, right? Okay, and that is not a fixed account. Believe me, Satvik, I am not from analog, but again, you can go for like some ADCs, DACs also, that could help you. Maybe like SAR, ADC, you can go. This is very good, which can be used in IoT applications. So these are like, some, projects for analog candidates. You can work on that, right? Okay. So three projects along with the work experience we need to mention. Yes, when you write any project, na, what you mention, what was the objective, what are the tools, and what are the languages you have used, and what you achieved in that. And if suppose you are working with a team, then what was your role in that team? Because if it is a big project, then you should mention your role also. Sometimes what happens, na, we are working on one project, but we worked on some small part of the project. So you should mention clearly. It's not, there is no harm in mentioning that, right? Okay. So that is also very important that you mention your portion, that I worked on this, but you should have a basic idea of the entire project also. All right, thank you, Garvit. Nice to hear from you that you are from UIET. Okay, I hope this session would have given a more understanding about the journey from ECE graduate to chip design engineers. So, all right, everyone, it's time to say bye bye. Thank you, everyone, to join this session. Okay, and I would be happy to connect with you people and give my knowledge to you. Okay, thank you, everyone. Bye bye. Have a nice day.